Now we call upon for the next and final session on new energies, Mr. Ashok Kumar Rajput. Mr. Rajput is a BTech in Electrical Engineering from GV Pant University, MTech from IIT Delhi. He started career as an engineer, operation and maintenance in 1986 with NTPC and joined CA in 1988. Since then, various level and work disciplines like operation of power system, electricity distribution, T&D losses reduction, R&D, renewable energy technologies, and monitoring of RE generation. At present, he is the member power system at CA. Sir, we welcome you. The moderator for today's session is Mohammad Saif. Mr. Saif has more than 16 years of industry and power sector consulting experience with Big Four Consulting. Currently, he's a part of EY's power and utilities team in the Africa, India, and Middle East region. Practice lead for energy efficiency, decarbonization, and emerging technology segment, as well as all traditional value chain covering electricity generation, transmission, and distributions across business strategies, transition planning, innovative business model, transition pathways, etc. We welcome you, sir. We have the another speaker, Mr. Megha Jalaluddin. He's an experienced chief retail officer with a demonstrated history of working in the utility industry, skilled in business planning and transformation, energy customer service, risk management, and project management, strong business development professional with an Asian leadership program focused in business leadership from Cambridge Judge School, Business School. We welcome you, sir. We have Mr. Devi Prasad. Devi Prasad is currently working as the Executive Director with India Energy Storage Alliance at Customized Energy Solution. He has been involved in techno-commercial feasibility strategy formulation and consulting in emerging technology areas like energy storage, advanced battery, renewable integration, green hydrogen, smart grid, electric vehicle, infrastructure, and microgrid. We welcome you, sir. We have the next panelist, Dr. Shivani Sharma. Dr. Shivani Sharma is a principal technical consultant, power consulting Hitachi Energy, a seasoned professional working extensively for more than 16 years in the energy industry and futuristic smart grid, making outstanding technical leadership contribution to energy transition, R&D, power system analysis, EPC, and detailed design engineering across geographies. We welcome you, ma'am. We welcome Mr. Tobias Winter. Mr. Tobias holds a degree in Business Administration of the Rhine-Westphalia Institute of Technology, Aachen. During his career, Mr. Winter has gained professional experience in renewable energy and energy efficiencies and project across corresponding legislation in Germany, India, Argentina. We welcome you, sir. One more seat. And the final speaker for today is Mr. Yasin Chaudhry. Can we have Mr. Tobias? Coming. Mr. Yasin Chaudhry is the IAS officer of 2015 batch. He has a BTech from IIT Roorkee and a master's in public management from JNU, New Delhi. He has been Vaughan Lead Fellow at the John F. Kennedy School of Government at Harvard University. He has worked with TUV Rhineland in Europe with Oracle Financial Services in India. He has additionally worked at the International Center for Democratic Transition, Budapest Initiative of Change International at Switzerland and Gateway House, Indian Council of Global Relations, Mumbai. Since joining JNK cadre of IAS, he has served in Baramulla, Katwa, and Rasai district. He has also served as the MD of the National Health Commission and CEO of Ayushman Bharat PMJ and state-level nodal officer for COVID control during successive waves. He is currently MD of Kashmir Power Distribution Corporation Limited. We welcome you, sir. I now hand over the mic to our moderator, Mohammad Saif. Over to you.
Thank you, Dr. Saad. Good evening, everyone. We have already had the introduction of our esteemed panelists. We'll start with Rajput sir, who will be giving a keynote address to kickstart this session on new energies. And post that, we will have a question and answer session. But we'll start with, after the keynote session, with Mr. Yasin. And he has a small presentation to show on how J&K is working in the clean transition journey. And after that, we'll have a set of question and answers from the other panelists. So, Sir Rajput, sir, the keynote session.
Thank you, organizers, and thank you, Mr. Saif and other dignitaries on the dais. I have the honor of working with so many of the professionals here on the dais as well as in the audience also. And first of all, I should say good evening and good afternoon to everybody. That is my duty. And also a welcome to the participants from here and participants from abroad. So basically the topic given to me, which has been assigned, that what are the new sources of energy. I would say that all the sources of energy are new to a human being. And particularly when the human being start using the energy, everything is new to him. So we have to see the energy sources in new perspective. That is the precise topic. What are the energy sources and what is the new perspective, how we can do better. So daily we are trying to do better and better, whatsoever the existing things are there. And we are lucky that India is the most diversified in the world. There are diversified sources of power generation. They range from the conventional sources to the alternative or the non-conventional sources. India is lucky to have both the resources in abundance. And it's up to the human capacity, up to the capacity of the government here and the manufacturers and entrepreneurs here, that how much they can exploit. That's why Honorable Prime Minister has rightly set the target that in coming years, say by 2030, that is 2030, we'll be having more than 50% of the energy from the non-fossil fuel of non-fossil resources. So that is one way of approaching towards the net zero conditions, and the net zero targets for us are 2070. So naturally there will be intermediate targets also. Energy security and energy independence we are planning to achieve by 2047. So we have to promote the sustained and the sustainable growth, and that growth will be attained when we start harnessing the energy from the renewable sources of energy. But we have to keep in mind that overall 100% renewable sources of energy cannot meet our requirement as far as the energy security is concerned. For energy security, we have to have some base in the form of the conventional resources, and coal is obviously the first choice as per the present constraints given to us. Gas we do not have, otherwise the gas could have been the best resources for absorbing the challenges of variability and intermittency. So generation sources alone cannot do the justice. We have to have the strong transmission and distribution network, and we have got a very good interconnections of the transmission lines right from 765 kV, 500 kV HVDC, 400 kV, 220 kV, and down below up to the distribution level. Another attempt which we have made in the zeal of our energy needs is the interconnection with the neighboring countries. So neighboring countries interconnection is in a very progressive state. We are having from the Nepal, Bhutan, Myanmar, and Bangladesh. With these we have interconnections. And another interconnections which we are planning is the BIMSTEC, which will be connecting up to Myanmar and Thailand. Sri Lanka also will be there. Then another interconnection which is being planned or which is being thought, which is at the policy radar of the government of India, interconnection of Maldives with the undersea cables, and also interconnection with Singapore. So these are the areas where lot of work will be coming up and lot of opportunities will come up. To Singapore and Maldives, our attempt will be to supply the renewable sources of energy. Another target is that of the electric vehicles, that how we achieve. By 2030, we have to achieve, the target is 30% of the vehicles as electric vehicles. and naturally it's in line with the 2070 target. So far, the achievements in the form of the renewable energy are around 177 gigawatt of the non-fossil waste installed capacity, of which 7 gigawatt is the nuclear capacity. But in the coming plans, coming years, we have higher importance of the nuclear energy also, and we will see a higher capacity soon. Large hydropower at present is around 47 gigawatt, and more has been planned. But as you know, in the hydro, gestation period is large, and naturally the environmental or the geological challenges are more. So we have to cautious. So we have to have the plan A as well as the plan B. And one of the thing Indian power sector has been, because we are agrarian based or the agriculture based economy, the water power nexus has been there for irrigating our crops and producing the food. That's a good thing, that with the use of electricity and the water from the ground, we are able to produce our need of the grains, food grains. So this water power nexus is also now coming to the end, reason being that the solar feeders have been specifically created, and during the solar hours, the energy is being supplied to the irrigation pump sets, and that is reducing the burden on the conventional grid. Another initiative which has been taken in this direction to achieve the fast capacity addition of any kind and to evolve the transmission and distribution system and also the supporting communication system, that is the PM Gati Shakti mission. PM Gati Shakti mission, in short, in very brief, is that it's an approach towards the seamless interaction or seamless interfaces of all the different infrastructure sectors, so that there is a better coordination and better planning and the minimum difficulty in implementation. We have to keep in mind also that fossil fuels burning can meet our need, but they are very harsh and they harm the environment, and also there is a concern of their depletion. So we focus more on the alternative sources of energy. In that, naturally, the solar is one. And in case of the solar, statistics says that India is receiving 5,000 trillion kWh per year energy. And we are receiving the solar insolation of the order of 4 to 7 kWh per square meter per day. So this is sufficient to meet our whole energy needs. But the technology has to support it, that is there. Solar energy potential, considering that 3% of the wasteland will be covered, is about 750 gigawatt in the country. Kusum Yojana, that is the Kusum scheme, is proving to be very useful, and it's proving to be too useful that the farmer, even a farmer, has become the energy producer, that is the prosumer of electricity. Earlier were times that when he kept on waiting when the electricity supply will be available and he will be able to run his activities. Various policy measures are also in place. One of them, the prominent, is trajectory for renewable purchase obligations. So a renewable purchase obligation trajectory has been specified, which will help in promotion of the renewables. Waiver of interstate transmission charges for the RE projects, must-run status to the RE projects, and also must-run status to the given hydro projects. Guidelines for procurement of solar power through tariff-based competitive bidding are also there, and standards for the deployment of solar photovoltaic has also been formulated. So all these efforts are helping us in adding more and more capacity in the form of the renewable. Building bylaws have been changed so that they will facilitate the creation of the rooftop solar. Infrastructure status has been granted to the solar projects. Raising the tax-free solar bonds, providing long tenor loans from the multilateral agencies are other supportive measures. We have around 64 gigawatt of solar power installed capacity, both rooftop, floating solar, as well as ground mounted. Another initiative at the international level which has been taken, for which the countries have united together, India being the founding member of the International Solar Alliance, we have given the concept of one sun, one world, and one grid. This is a concept mooted with the fact that the sun never sets in a globe any time. If in one part it is not visible, in other part it is visible and providing the solar insolation. So one part of the solar energy rich states or the countries will supply to the another countries when the solar is not available in their territory. So this is the concept of one sun, one world and one grid. We should focus more like in African countries, it has been a success that the solar plants with thermal energy storage. Solar plant with thermal energy storage, we are not having too much or only you can say maybe the experimental one only. So these concentrated solar plants we should have, they store the thermal energy also and they are not suffering from the variability and intermittency, and even when the sun is not shining, the energy can be generated. In this direction also come the 24/7 availability of the fuel sources, that is the waste to energy. Why I am mentioning here waste to energy is because waste to energy, if the waste is allowed to rotten freely, it will have the six times green global warming potential as compared to the 1 kg of burning or the combustion of the waste. So that is quite harmful. Waste to energy plants also releases the useful land for further dumping and also clear the land which has been occupied by the waste dumps. Employment generation in all such activities is the added advantage, and employment generation is not only in the electricity sectors. When the economy improves because of the electricity usage and the electricity supply conditions, the manufacturing sector gains in terms of the equipment manufacturing and the employment is generated, and this is a interdependent chain which is very useful. Wind energy, so far we are having only the ground mounted or the onshore wind resource exploitation, and we are planning that in near future there should be offshore wind development also. Challenges in the offshore wind development will be the undersea cables, transfer of power, and also the technology, because India has got around 80% indigenized or 85% indigenized in terms of the onshore wind power technology. But in case of the offshore wind turbine, we have to depend for the capacity on other countries. So man and material as well as the technical resources will be the requirement. And we should not confine, when we talk of the energy, we should not confine ourselves only to the electricity, because there are various forms of energy like the primary energy and the secondary energy. So we should consider the nature's gift, that is the biomass. We are quite abundant in the biomass, and we have got the potential of around 750 million metric tons per year, of which 230 million metric tons per annum can be spared, and this tantamounts to a potential of 28 gigawatt of electricity. There are various technology of conversion of the biomass into the electricity. Let me be brief and come directly to the ocean energy. Ocean energy is also untapped, that is the new form of energy, and in the form of the tidals, the OTEC, ocean thermal energy conversion, by using the temperature gradient of the upper layer of the water as well as the deep sea water, we can use the ocean thermal energy conversion principles, and that can also be utilized. For tidal energy, though it is costly, but there are some sites which can be exploited, and maybe the technology can help, or the experience of other countries can help. So we can name the wave energy under the head of the ocean energy, the water current energy, and the ocean thermal energy. Then we come to the fuel vents. Those fuel brands are biofuel and the biodiesel. So bioethanol also we can have, and biodiesel also we can have. Ethanol blending we can have up to certain percentage. Otherwise, if the higher percentage is there, we have to make changes in the IC engines to some extent. For the biodiesel production, used cooking oil has been considered as a good feedstock, and that is being utilized. Biogas also similarly, under the anaerobic digestion system of the biomass, and whatsoever the residues are there or animal waste is there, we can use the biogas. Biogas can be cleaned from the carbon dioxide, and it becomes of the natural gas standard or like methane. So we name it the biomethane that we can use in different forms. Biogas in a compressed form can be used as a vehicle fuel also. Similarly, the condition with the bioethanol, which I have just described, bioethanol is also oxygenated, thus proving the potential to reduce automobile emissions. In case of the offshore wind, the policy is in place in October 2015, and the potential areas are Tamil Nadu coast as well as the Gujarat coast. So these are the potential areas in the beginning. Others could be find out later. In case of these turbines, limitation will be having the HVDC cable and HVAC cables, which are the undersea cables. If the need arises, this technology could be transferred, and this manufacturing can take place in India. In case of the offshore wind installation, the lightning strikes probability is more, and we have to test our equipment for the lightning protection also. Size of the turbines in case of the offshore turbine is ranging from 8 to 14 megawatt, whereas in case of the onshore it is 2 to 3 or 2 to 5 megawatt size. But advantage is that the capacity utilization factor of the offshore wind is higher because the wind is not having any obstruction there, and thus the energy produced will be slightly cheaper had it been the same capacity on the ground. National Institute of Wind Energy is there, which is making the estimates for the wind energy potential in India. Another untapped energy is geothermal energy that we have to tap. Geothermal energy has got the advantage that it is 24/7 available. It is renewable form of energy, and when the excess energy is there, then the demand, the hydrogen, green hydrogen can be produced. And green hydrogen is basically a wonder which everybody is talking of, and naturally it will lead to the hydrogen economy. We have got the potential in Jammu and Kashmir, that is Nubra Valley, Chumathang and Puga Valley for the geothermal, Cambay in Gujarat, one Tatapani in Chhattisgarh, Khammam in Telangana and Ratnagiri in Maharashtra. These are some of the areas. Another areas which are of a different type of the geothermal energy, that direct heat could be utilized.
Sir?
They are in Bihar, Manikaran. Just 2 minutes you give me. Hydro energy is another energy carrier that we have to exploit, and we have to make use in producing the green energy, that is the green ammonia, and green ammonia can be used in the furnaces along with the coal. That is the biggest advantage. So as far as present conditions are considered, around 25% of the heat value, the green ammonia has been fired into the coal-based thermal power stations. Later on, this percentage can go up. This hydrogen and ammonia can also be utilized by changing the combustion chamber of the gas-based turbine, and there also there will be reduction in the CO2 emissions. Small modular reactors, in our present circumstances, we should not forget, and these small modular reactors have various advantages over the conventional nuclear reactor. Floating solar, I have specified that the floating solar has the advantage that they do not require the land, and the water quality as well as the operational performance of the solar panels increases. Another need is carbon capture, utilization and storage. That depends on the technology, that what type of the technology we'll use and how much maturity we can get, but this is naturally an area which is untapped. Energy storage will play its role, and along with the energy storage, we have to see the pump storage plants also, on which the more emphasis is there nowadays, and then off the river, pump storage plants are there, for which the gestation period is less and lesser number of clearances are required. So anyway, technology is ever changing. We do not know what breakthrough will take place, and we may be gifted with another form of the energy. Thank you.
Thank you very much, sir. I think what you have done is you have listed most of the new energy options that are at mostly nascent stages, sir. And I'll just give a quick 1 minute context before I'll ask Mr. Yasin for his presentation, that the concept of new energy for this particular event was something which is different from the traditional renewable sources that have been used across the world, primarily solar and wind. And how it is different and why it is needed is that if you look at the time horizon since the Paris Declaration, in next 2 years we will be having somewhere around completing the decade since that declaration, which first announced keeping the temperature within 2% limit of 2 degrees of the pre-industrial area, and later it was decided that the limit would be kept at 1.5 degrees of that pre-industrial era. Over these 7-8 years, what we have seen, if you see the trend, the carbon dioxide emission, or in total the GHG emissions, have been rising. And while we have been putting on renewables and the growth has been very, very good, but if you look at and compare the growth trajectories of both carbon dioxide emission, as well as the renewable energy capacity addition, we are seeing that the carbon dioxide emission is still outpacing the renewable capacity additions, which means there are requirements of some complementary initiatives which we have termed as new energies. And these are those initiatives that are either a combination of the traditional renewable sources or newer areas of work where either from the demand side or from the generation side, we can have these initiatives to complement the traditional use. So most of these initiatives have been listed by Rajput sir in his keynote speech, but some of them which are critical is using a hybrid solar, wind and storage mechanism, or using a green hydrogen at the demand side, or using newer ways of improving the energy efficiency, like using storage at household level or a retail level. So with this, I'll give the dash to Mr. Yasin. And the question, I think the agenda here is that we would like to know how the Union Territory of Kashmir is progressing on its overall green initiative, and specifically the new energy initiative, sir. I think geothermal, as Mr. Rajput mentioned, is there in Kashmir as a major area where it can be tapped. So let's see and listen from Mr. Yasin.
Right. Very good afternoon, everyone. I promise I will be short. So firstly, it's an absolute privilege to speak here. I must congratulate the entire team, Mr. Agarwal, Mr. Gandotra, Dr. Farooqi, for the stupendous success of an event. In fact, I congratulate the whole team at EMA for pulling this off, particularly the WUS team. It was a pleasure listening to such major stalwarts of the sector over these 2 days. Just a disclaimer, this presentation is not a self-celebratory thing where I'm going to talk about how well my DISCOM is doing. In fact, if not anything else, I'm going to talk about how bad my DISCOM is doing. But to be honest, I wish to give you all a perspective of what is it that we are able to deliver in Kashmir. Post Article 370 revocation, after decades of resource plunging, where do we stand as far as the electricity scenario there is concerned? And then I'll come a bit about new energies there. But in the context as to how we try and plow new energies into a very archaic and conventional DISCOM ecosystem. But to be fair, our reality is bleak. We are one of the, my DISCOM has one of the highest ATC losses in the country. It was 62.55% in the last financial year closing. Right now, the cumulative stands at around 55. I wish to give you an overview over about what and where we are. So this is Kashmir, and to be clear, we have around 12 lakh odd consumers, and as of now, the ACS ARR gap stands at 3.82%, which is much, much higher than the national average, which you know is 0.6%. Now, my DISCOM is actually a very young DISCOM. We unbundled just 4 years ago. And in fact, we have still not unbundled perfectly. Our power purchase is still taken care of by the government. From next month onwards, we plan to take it up ourselves. But long story short, we are still grappling with a lot of typical old school issues like load shedding, schedule curtailment, distress curtailment, and it's majorly all firefighting that we do most of the time. And that's because we face the brunt of a very harsh winter full of snowfall, unlike any other part of the country, and where the load demand shoots up exceptionally high, much more than, say, what Delhi or Jaipur would be in summers compared to what Kashmir is in winters. It jumps up by a good 50%. So there is no autopilot for us, or rather our autopilot is not strong enough. So more often than not, we are, our men, our people on the ground are basically more involved in trying to make sure that the lines don't snap and the faults are traced and the damaged DTs are replaced on time. So this is where we are, and I wish to show how we are going to go ahead from there. Now, a bit about our existing infra. So I would bring to your notice a large number of receiving stations, 303 receiving stations for a population of, for a consumer base of just 12 lakh consumers. And this has been also thanks to the huge investments that have poured into expansion of distribution infra over the last many years, starting from IPDS, RAPDRP, PMDP, DDU-GJY, and so on and so forth. It makes for a very good photo op inaugurating new receiving stations, but let's also accept that in leaky bucket of a DISCOM infra, creating more receiving stations is akin to punching more holes into that leaky bucket. So this is what has forced us, has actually pushed us into facing more losses, giving more access to our consumers to take away electricity. Now, the other point that I would like to draw your attention upon is the huge number of feeders, and particularly the line lengths, both HT and LT, signifying very long feeders, especially in the rural peripheral districts outside Srinagar, where villages are very verdantly located, houses are very far apart from each other, and more specifically, the extremely poor metering coverage. Only 30% of my consumer base is metered. And one more thing that I would like to draw your attention upon is that the disproportionately high number of domestic consumers I have. Kashmir doesn't have a lot of industry. In fact, it has less industry than Jammu does, just for your information. So I don't have that much industrial consumption as well. Commercial is also quite negligible. Agriculture is non-existent, even though we have lush green paddy fields and apple orchards, but our farmers, our horticulturalists do not actually use dedicated agricultural connections for their farm use. So this gives you an idea as to why the major bulk of, how the major bulk of our electricity is being consumed in homes. As I said, very poor metering coverage at the consumer level, and DT metering and feeder metering is almost non-existent. This is where it has led to an extremely low billing efficiency, 41%. I mean, we don't even know who's consuming 60% of our electricity, obviously attributable to, say, power theft or hooking or, misreading of the misassessment of the load per se. Another point, our collection efficiency is still somewhat better. However, power purchase. So, just to give you an idea, every year Kashmir is supplied with electricity worth 5,000 crores. That's our power purchase bill. And to set aside the fact that we actually don't pay our own Genco, we owe them thousands of crores over so many years. And against this, we only get around 1,500 crore from our consumers. So, yeah. Further, this is how our ACS-ARR gap has been going down. We do have a plan in hand, thanks to RDSS, but it remains to be seen how. But it has improved. It has improved from 3.82 to 2.41 at the moment. Now, as I said, these are the issues which we've realized leading up to our losses. Long feeders, overloaded DTs, unmetered consumers, low billing efficiency, power theft. Now, one major thing which I want you all to take away is to understand why our problem is exceptional. And it's because of our intense and extremely huge heating load. See, unlike in other areas of the world where it snows as much as Kashmir, heating load is on gas or some other non-electricity source. As you know, in Europe or in the US, domestic heating or even institutional heating is done through a network of piped gas supply. We don't have that in Kashmir. Now, traditionally, in Kashmir, everybody has been using fuel wood. And we had the concept of a hammam, which is basically a underground cellar below our kitchen, which would where the wood would burn and the whole family would sit and spend the whole day during harsh winters. What has happened is that the changing lifestyle has actually shifted us from that communal living to a position where everybody is living, staying in a room of his own with 2-3 heaters of his own, AC of his own, and that's where the heating load goes up, all on electricity. No gas, no firewood, no fuel wood, whatever. Another thing is the proliferation of, or rather excessive, building of new houses that has happened in Kashmir. And this is a well-known fact that Kashmiris love to build houses. Anybody who's from rural Kashmir would want to have a house in Srinagar, so that's where the second house comes in and more consumption. And more specifically, the breaking up of traditional joint families to nuclear families as well. So fuel wood going is a good thing for the environment, but of course, when we are not having a sustainable alternative, then all the load will fall on electricity. An interesting observation that we've had is the impact of Ujjwala, the free LPG connection scheme. So essentially, what used to happen is, at least in the urban areas of the towns, if not electricity, people would use a gas bukhari. A gas bukhari is basically an LPG cylinder fed flame heater. And what happened when we started mapping LPG consumer connections to Aadhaar, we curtailed the access to LPG for people who were additionally using it for heating apart from cooking. So that also went out of the window, and everybody then more than ever before shifted to electricity. And as I said, no alternate sources like gas. And yeah, our curse, nichrome coil heaters. They have devastated us more than anything else. They're used rampantly, abundantly, without any limitation, and by all sorts of people, poor, rich, middle class, you name what. And crude boilers to heat water, and not a more efficient geyser. So what exactly do we face in winters? So just to give you an idea, my peak load in the winter touches around 2,700 megawatt. In fact, this year it touched 2,750 megawatt. But we're not meeting that much load, of course. This is the demand I'm saying. Against that, we provide 1,700 megawatt. The rest we just can't afford. As I said, the power purchase bill, and I'll give you an idea about that also. Over the last 4 years, the government of J&K has spent 25,000 crore rupees on power purchase alone. Most of it was sponsored through PFC loans. In fact, just 3 months ago, we took another loan worth 3,500 crores to pay back loans that we had taken in the past. So all that, this large, almost 1,000 megawatt gap, we're not able to afford. And the 1,700 has also been, pushed from 1,550 megawatt. We had to go for an additional power purchase this year. Now, the limited the supply is obviously, induced through, is regulated through curtailment. And what happens is people are not obviously, regulating their use themselves. So even against a flat meter connection of half a kilowatt, everybody is consuming, say, 5 kilowatt. Resultingly, their local DT goes bust. My DT damage rate in peak winters touches 6%. And I have a DT strength of almost 40,000 distribution transformers. So you could imagine what a field day our staff has in repairing so many DTs and making sure they go on time. In fact, we have a turnaround time rule, 12 hours in urban areas, 24 hours in rural areas, which we still find difficult to live with. So we're very, very far away from the dream of having 24/7 uninterrupted power supply in Kashmir. In fact, in my worst case scenario district, which is Kupwara, aspirational district on the LOC, I am only able to supply 14 hours in today's age. Now, the inference here that I'm drawing is that with such, the proof being the high DT damage at local level, indicates that there is a strong need for having an alternate load sharing localized generation sources. And this is where we come to RE. Now, to be fair, we haven't been doing extremely well on RE either. There's been, agricultural pumps under Kusum, smart city, rooftop installations, small hydro, and so on and so forth. And we're aspiring to attain 2000 megawatt by 2030, but we are frankly very, very far from it. That's actually my office. We have one over there as well. We're trying to make use of this opportunity of RDSS and PMDP smart metering, because smart meters are all net meters. So we're trying to make sure that we push solar rooftop scheme alongside, so that the net metering purpose can also be used. However, the uptake has been poor. And why? And I attribute it to 3 reasons. There's been sharp escalation of rates of PV panels because of high custom duty, which is making it really unviable. Then there's a lack of enthusiastic response from vendors, and there's a lack of consumer confidence as well. And why is that? Because, see, unlike using solar in a place like Delhi or Jaipur, or where if the sun is shining, of course, production generation will be high, consumption will also be high. So you're able to meet your peak of the day, time of the day peak. However, in a place like Kashmir, when it's cloudy and snowing, obviously demand will be high, but production will be minimal. So it effectively fails in the winters. But I won't use such a harsh word like fail. I mean, it's still able to generate significantly to contribute in a purposeful manner on better days. Some examples of our projects, PM Kusum solar pumps. Yeah, small hydro I want to touch upon briefly. It's again been a disappointing non-starter. Okay, big hydro obviously is a success. We have very advanced installed capacity. But again, the issue comes in winters, the lean season generation is at an all-time low. We are only able to get around 200 megawatt in peak winters as a part of our 1750 megawatt, and that's just for Kashmir, I'm saying. So you can assume that almost 1600 megawatt we are purchasing from the energy exchanges. Small hydro has been a disappointing non-starter, and more specifically because IPPs are really not able to get PPAs which are attractive enough, even though we've tried helping them a lot. To be frank, those under EPC mode have turned kaput because of the funding under PMDP getting plugged. We really don't have money to pay the SHPs also. As it is, the other GenCos that we take electricity from, we owe them a lot, but here as well. So that's pretty much some example. This is Baltikulan in Gandotra. And yeah, that's all. The conclusion that I want to draw is that I feel apart from the loss reduction solutions like metering and cabling, the demand side management, and especially through decentralizing generation as much as possible, that's where our deliverance lies. With this, I take the opportunity to welcome you all to Kashmir, to please come there and help us solve our problems. Thank you so much. Thank you.
Thank you. Mr. Chaudhary, I must say this has been one of the most frank and most transparent presentations of the entire event, I think. Thank you so much for sharing the things, and I'm sure under your leadership it is going to go much, much beyond. So, yes. And so with this, what we'll do is we'll quickly have a round of discussions. I'm sure everyone would be waiting for the chances, and due to paucity of time, earlier the structure was that I was thinking to do 2 questions per person. What I'll do is that I'll ask both the questions together, and please be with me and give the answers accordingly. So I'll start with Datuk Megat. Sir, you have a very advanced electrical infrastructure and a consumption pattern as compared to India. you have a very strong per capita consumption, which is to the tune of 5,000 kilowatt hour per person, unlike in India, which is almost nearing 1/3 of that. But, and similarly, the carbon footprints and the energy dependence on fossil fuels would also be higher. So it would be great to share your experience and your plan on how the energy transition is happening in the country and what India can achieve through your learnings, if there are certain things or challenges that you are feeling. So, sir, over to you.
Good evening, everyone. Thank you very much. First and foremost, thank you to the organizer for having me here. Happy to share some of the journey that Malaysia as a country goes, as well as the journey of Tenaga Nasional, which the company that I'm working at the moment, which is the largest utility company in Malaysia, and we are actually involved in the whole value chain of electricity, from generation, transmission, as well as distribution, up to the retail customers, meaning that we are an integrated power utility company with 10 million, around 10 million customer base. The interesting fact about the landscape of the country, in terms of the supply side, the generation mix, at the moment we have mostly based generation by the fossil fuel, 45% from gas, 45% from coal, and the balance is actually from hydro, which is coming from, sorry, the balance is the green generation, mostly coming from the hydro and the solar generation. And from the demand side, we are also seeing the country is actually having a good growth rate. The pre-COVID growth rate was about 3 to 4%, and as of today, I think we have come to the level of the so-called maximum demand, coming back to the pre-COVID level, and we anticipate the growth will be around 3 to 4% in the years ahead. So those are the landscape that we have today. And recently, the government of Malaysia has made a pledge commitment based on COP26 to actually achieve a target of net zero emission by the year 2050. So that poses a challenge to a power utility like Tenaga, and also provide the opportunity for us to move forward. So the response from those commitment by the government is that we, the company, is also taking a similar step, that we definitely want to reduce the generation from the fossil fuel, especially coal, meaning that we want to decarbonize. But at the same time, we know that it's going to be a transition because the market is actually growing. So we have also made a pledge that by 2050, we want to achieve the net zero emission. At the same time, we hope that by 2050, we have a zero generation of coal from the power system. And we have some key milestone with respect to the mid-year 2035. We want to reduce the coal intensity by 35%. So those are the so-called the landscape that we are seeing today with respect to the Malaysian journey. And we think this is a transition. And so the company believes that this energy transition will require a good planning and initiative to be able to achieve those objectives. So in that sense, what the company from the strategy point of view has come up is we are looking from 3 pillars of energy transition. The first one, we are basically looking from the energy sources itself. As I mentioned, this is where the opportunity for the new energy space to come in. As I mentioned, solar is, we are blessed with solar. We are having about 4 to 5 hours a day of a good solar generation throughout the year. So we have a single season in Malaysia. So solar has taken a very good growth rate in the last 2 years with respect to the solar rooftop as well as the formation of the large-scale solar. So that is the energy which I think we believe that is the current energy to increase the RE capacity for generation. The second one that we are looking at from the energy sources is with respect to biomass. The country is also blessed with palm oil plantation. So we have started a number of projects that use the empty fruit bunch from the oil palm to actually generate electricity. So those are two elements that we are looking at. And the third one is actually we are also seeing a good conversation happening with respect to the nuclear energy, in the sense that everybody talking about energy transition, but I think we have not found the solution to replace coal. We understand that solar is there, but everyone know it is a intermittent kind of sources. So I think the key for the energy sources for the to achieve the energy transition is actually to find what will be the replacement of a permanent generation like coal. We believe that nuclear could be the answer to that, and I think the conversations about nuclear has again resurfaced in Malaysia. I mentioned why it is resurfaced, because there was a conversation 20 years ago until Fukushima come to the picture. But today we are seeing that the conversation has come, and again, and it is focused mostly with respect to the latest third generation nuclear technology related to the SMR, small modular reactor, that is actually beginning to take place within the power sector. So those are the energy sources that we are looking at. The other part is the second pillar we are looking is we term it as energy vectors. That we are looking at the two main technologies with respect to energy vectors. One is actually hydrogen. There is a number of work that is being done to encourage the hydrogen creation of the hydrogen market, taking into account the utilization for the power sector, mobility, as well as the industrial use of green hydrogen. The second technology that is very much in the pilot stage is the battery storage for the grid as well as the customer. We understand that the battery storage is also is a good technology element to ensure that we remove the peak of the power system, but at the same time it provide a good storage when it is required. So these are the two energy vectors that currently we are looking, hydrogen and battery is already in a pilot stage on the customer side, and it's going to be a pilot for the grid as well. The third bucket or the third pillars that we look at is actually on the demand side, which is the energy usage. In terms of the energy usage, the key element that is happening in Malaysia is actually electrification of transport. Tenaga Nasional as the main utility, we have taken up the role to ensure that we provide the electricity to all the charging point operators. But at the same time, we are also installing our own chargers across the country. So this is one element that we see that getting a good momentum, and we see that also at the moment there are about 13 international players of automakers bringing their own brand to the market. So we think this is going to be a good positive growth for the business of electricity, but at the same time achieving the net zero emission for the country. As we are aware that the transport sector is the second biggest contributor of carbon emission compared to the power sector. So those are the landscape that we are working on. And to the second question by Saif, what kind of elements that we can share to the others? I can basically pick up three points in the journey that we have taken so far. The first is actually on the customer. Customer engagement and participation early, at the early stage, is very, very important, especially when we talk about going through the journey of solar rooftop as well as the electrification of transport. So the first key is actually customer participation as well as engagement. The second point that the learnings that we have learned is actually on collaboration. It is important for the players within the industry, especially the big players, to start collaborating to achieve speed and scale. I think, and the collaboration can be in the form of multi-industries. For example, it could be from digital, transport, as well as power industries. The third point is always, I think, is about regulatory and stakeholders engagement. This is basically very, very critical, especially we want to introduce new energy to the space of power, a lot of syndications with the stakeholders so that the policy driver understand the needs of the market and at the same time guide the market to those objectives. So those are the 3 points that I think worth mentioning as we go along the journey. So thank you, sir.
Thank you very much, sir. I think there is a very clear roadmap that you have in mind for the country, especially with a very rational target of net zero of 2050. I think it is going to be achieved with the plan that you have, the blueprint that you have. And also thank you very much for sharing the 3 key critical success factors for such big transition. In India, a similar program, as I was mentioning, of rooftop solar, went through the same process of customer engagement and saw a lot of benefits and adaptation. So thank you very much again. Tobias, I think I would connect with you. The 2 questions for you were, one, we all know that power sector overall is a capital intensive sector, and when we talk about all those nascent new energy technologies, they are a little more capital intensive given that the maturity has not reached. So how GIZ has been working to promote these areas, these nascent technologies, that would be one. And the second one is that you've been working in India now. So what do you think for a country of India's maturity level when it comes to cleaner energy, what can be the learnings that can be there for other similar countries to take through?
Thank you very much. Thank you especially for the conference organizers for inviting us. Mr. Gandotra, thank you very much. Sri Rajput sir, Mr. Chaudhary, a pleasure to be with you on the panel. Let me quickly just answer that it's not so much about the capex, it's about the levelized cost. So whatever turns out to have the lowest levelized cost of electricity will be invested in, and this for Germany clearly is mainly solar and wind, plus more and more storage upcoming. I don't know if my colleague can maybe put up a slide just to kind of like compare the prices. I'll make it really short, but basically our message would be that we are jealous of the sun India has. You were mentioning the intermittency. If you just go next slide. So if you just see, Mr. KVS Baba was there, and I think Dr. Dam showed the slide yesterday also. This is impressive for us in Europe. Yeah? This is 365 days of solar generation in all over India. So yes, there is intermittency, but somewhere in India, the sun is always shining. And if you really have one nation, one grid, that means that the electrons can flow north to south, east to west, and that you have actually baseload solar. And this is something which is for hydrogen production and many other industrial applications. It's very much of interest. You please compare it to Germany. No, we have a factor of 32 between the lowest day of solar generation and the highest. India has a variation of factor 2 only. Yeah, so that's amazing. Next slide, please. Wind. There's always the question, what we do with wind. So this data, this is actually from CEA Posoko. So thankful to Mr. Baba and to CEA who have actually put up the actual generation data of solar and wind on daily basis on the CEA website. No? So we just downloaded it, put it in an Excel sheet, and made a graph out of it. So wind, we understand that India is always concerned, yes, but a lot of generation, 25% of the generation is happening at the monsoon time, and then you have a lot of excess of wind power during these months. No? But if we actually know that the peak demand of India is also shifting towards these months because of temperatures going up, then this doesn't seem to be so bad. Also the fluctuation, yes, it's more fluctuating than sun in India, but except for like 3, 4, 5 days on an all India level, India is pretty much blessed with the wind. And there, let me confirm to you that there is developers right now, including German companies, Windguard, which are actually screening all India for sites where the wind is more blowing in the morning when the peak demand is there, and where the wind is more blowing in the evening. And again, congratulations to India. India has excellent conditions for generating power from wind, more in the morning time and more in the evening time. So if we come to the next slide, if you can just switch to the next slide. So these are the data, I think it's already 1 year ago, but I'm really amazed. The Power Foundation of India brought it up. I think the data originally comes from Bloomberg. That has been published under the aegis of MOP. So you see India is maybe not having the best solar conditions in terms of solar irradiation, but India is able to generate the power at the lowest cost compared worldwide. So again, congratulations, you have baseload solar and you're able to produce the power at the lowest cost, yeah? So this is in dollar, so yeah, that would be something like 2 rupees above, no, between. And then wind, okay, India is not generating the wind at the lowest cost in the world, but almost at the lowest cost in the world, no? So again, congratulations. So if we now know that India is actually able to produce power during the day with solar on an all India level, and able to produce wind mainly in the morning and in the evening, then the question comes up, and that was the point of Mr. Rajput, sir, no? What do we do with the peak demand at night? And if everyone, as Mr. Chaudhary also said, now going for the evening in its own rooms, switching on the devices, and the power consumption comes up. That is the big question. Right now, what we see is we at least do not really understand why there is not more investment in wind. We understand that wind is more expensive than solar, but wind is blowing at the right time. And right now, for these time frames, India is paying and willing to pay 5 rupees and above. So if India is willing to pay 5 rupees and above for the morning and for the evening time generation, so to say, apart from solar, then maybe, no, it would be also very much of interest to actually first go for more wind and see whatever private investors actually are willing to put on the table to deliver cheaper wind power to the DISCOM. But then next slide, please. The question is what else? And there, yes, the debate is there, no, between coal and other forms, pumped storage, we understand that there is certain limitations to be extended. But if we see the development for levelized cost of electricity for a 4 battery storage in India coming down within the next years to something between like $67 to $80 per megawatt hour, so that would be 7 to 8 cents, no, per kilowatt hour. So that in rupees, how much is that per rupee? That's like 5 to 7 rupees, 5 to 8 rupees per kilowatt hour, no? And that's for 4-hour battery, one charge. So now there's smart people in India now, which are saying, why don't we charge the battery once with solar during the day, and then maybe at night with some other capacity, excess capacity, to actually have 2 charging and discharging cycles. Bam, cost goes further down. And then, I must really say, congratulations, India is on the best way to dominate a lot of countries on this planet in terms of industrial power, in terms of lowest cost of generation for green hydrogen. And I know that Europe is looking at India being capable to do these things. So far, the speed in terms of wind investments was not there because we saw that, okay, solar had priority, some overcapacities had been put in place in the past. But if India from now on takes the right decisions, you are very much able to actually dominate a lot of industrial sectors based on electricity in this world. So very much excited, and thank you very much for giving me the opportunity to kind of like show you the German perspective on the future oil of India, and yeah, how much impressed we actually are with the natural resources you have compared to us in Germany. Thank you very much.
Thank you so much. Thank you so much. A very important point is that the battery, even with a single charge, would be 1/3 of what the current cost is. So that means complementing it with the other renewable can actually be a game changer for the net zero ambitions. So thank you so much for showing these numbers and making it more, number driven, the analysis. I would just take the discussion forward with Debbie on the storage side only. Now, since you have shown the last slide, and Debbie, you know, there are 2 things that I wanted to ask. First, what do you think are the challenges and the progress happening when you talk about the large grid scale storage? And then the pump storage that is now getting back a lot of favor, as Mr. Chaudhary was also mentioning, and I am myself working with a number of states who are trying to come out with a lot of private participation in this. Over to you.
Okay. No, so I will not tell the challenges, but what can make it better. So there are 4 to 5 things what we expect both the state and central government to make it better. One is parity on the GST. Yes, lithium ion has been reduced, but other technologies has not reduced on the GST. Second one, when you talk about stationary storage, it's not only about battery. There are actually battery may be 40 to 50% cost of the system. There is another 50% is like BMS, DC-DC converter, there is inverter, PCS. So we have recently sent a letter to MOP, MNRE to reduce the GST for all other components. Why that will be at 18 or 28%. So that's the second ask. It will help actually the project and also decrease the LCOE. And the third point is about the behind the meter application. Where is the rooftop solar plus storage? Yesterday we had a meeting with MNRE. At the same time, when it is a CNI project, commercial industrial for critical infrastructure like data centers, hotel, hospital or something, when it is behind the meter, we just tell, don't give us any incentives, subsidies, schemes, but don't create a bottleneck for us. There are few states without taking the name, now they are started charging synchronous charges. So they are nearby states. Like if you are not injecting the grid, if the establishment like a hospital who need continuous power, currently they are paying multiple bills, like one bill they are paying to the DISCOM, the second bill they are paying to the diesel genset, the third bill they are paying to the STATCOM, the fourth bill they are paying to the voltage stabilizer, the fifth one maybe they are paying to the lead acid batteries. When they are paying multiple bills, and the solution is now rooftop solar and storage they are using in the behind the meter, so just leave them. Because they are also solving one of your issues, like if they are actually going to the net metering, then your actually load dispatch center will have a nightmare. They are solving your issue, so don't interfere on the behind the meter market. Because when a establishment feel that, okay, it is commercially viable, let them install the advanced energy storage system. So this is the third one we are asking from the state side. And the last but not the least, we are actually good phase in batteries, where both on the adoption side we are going, and there is also manufacturing we are going. There is 50 gigawatt hour manufacturing out of 30 gigawatt is already done. Then is Honorable Minister also announced in the first day of the meeting in the conference at Ilekrama, another 50 gigawatt hour BSS manufacturing PLI is coming. So when all these are coming, also support the chemical processing. So because that is a unique thing we're asking, like in the cathode manufacturing, in electrode manufacturing, or maybe anode manufacturing or raw material processing, help them in the chemical processing industry, like maybe a PLI for them, or giving the capital subsidy or fiscal subsidy. So that will help. On good part, out of all 12 PLI, they have given now zero custom duty for the equipment manufacturing. So such things actually create a overall ecosystem, not only the driving the market. So this is about what government is doing, what is the industry asks. Why I'm telling not challenges? Because challenges will be there. We have to find a way how to solve it. So this is the way to solve it. And regarding pumped hydro actually a very good technology and very proven technology and very old technology. Till date, around 60% of global storage projects are pumped hydro. Considering that, now the growth of pumped hydro is less than 4%. When battery projects are growing around 30-35% every year, pumped hydro is less than 4%. There are multiple reasons. The reason is not only about what I wish. It's about how it is operating, or how much time the water availability, what is the environment clearance. Don't mechanize it. Whenever there is a long duration storage like a 10-hour storage or 12-hour storage we need, pumped hydro is good. But don't expect like pumped hydro to solve your grid issues in the picking up the thermal plants at the, or you can ramp up, ramp down time, or it may be frequency regulation. That is impractical expectation. So it's not a Swiss knife to solve everything. It has your own pie. So let's use it whenever you are required it. Don't try to address everything. That is the main problem. Like now the number of pumped hydro project which is operational, now we're talking more than that actually in the forums. So it is talking about pumped hydro, it will not solve. We have to find out why the 60% pumped hydro project which is in India is not operating for 365 days. That is not operating. That is just operating seasonally, partially. And so we have to find a way how to maximize get benefits of a pumped hydro. Just doing a project, leaving it on a pen and paper will never solve an issue. So we feel as a technology agnostic alliance like India Energy Storage, we are not a electrochemical or battery alliance. We feel all technology have their pie. It is not a pumped hydro. Other form of gravity storage, which may be a gravity city, or it may be Enervolt, or it may be any type of mechanical storage. They have also similar opportunity in a mechanical way. So all these technologies have their own application, but limited areas. Like you don't expect a pumped hydro to support a data center, but it can support for the shifting of the power. If you have a large solar plant, you are shifting 10-hour system to taking from daytime and storing to the evening, it can. It can also work as the inertia for the grid. So few applications, it is actually excellent, but excellent considering addressing the current issues. If we can address, it can actually help not only in India, it can help across the globe. But what I want to tell, let's have a technology agnostic approach to the industry, whichever giving you low LCOE, very modular capability, like today we have a 1 megawatt substation project, and tomorrow the substation issue has been resolved, take that batteries to another substation. So that's the way we should leapfrog to making the grid smarter.
Thank you so much. So the main message is that it has to be more economy driven and a SLA based thing rather than focusing on a particular technology when we talk about a storage. So last but not the least, Dr. Shivani, you've heard the experiences, you've heard the analysis, you've heard the issues, you've been working as a consultant, and you have worked with a lot of governments. You've seen how the Indian government has actually moved very fast on a lot of policy dimensions across most of this new energy, including storage, hybrid, and everything. What I would like you to share to the audience is, what do you think can be done to bridge the gap between this policy and execution? And is there anything which you feel from the policy side there can be more thrust or anything which is missing that can drive this implementation on ground?
Thank you, Seth, for that tricky question. And the last one. So my co-panelists have, already covered many points, and thank you to the participants for being here. I'll keep my message very crisp, taking it ahead from my other co-panelists. So as Rajput sir mentioned, the correct and the new kind of energy mix that you would see in the coming days in India. As Tobias has said that, he's jealous of India. So I have to say that yes, we have God's gift, which is renewable and all other good source of non-conventional resources. And since it's God's gift, we try to utilize, we try to store it as much as possible. And when we talk of renewables, the intermittency, the major trilemma of energy that we face today is related to one, affordability. So affordability, I think it's very well covered by my co-panelists. It's always a tug of war which happens that one, the manufacturers want a government policy in place, and second, the government would like to find the roadmap and then issue their policy. Now coming to the specific topic of today, which is new energies, we have discussed a lot of solar, we have discussed a lot of large wind parks and how they get integrated at the transmission level. When we are talking of new energies, it would essentially talk of green hydrogen, it will essentially talk of battery energy storage system, it would include nuclear, transportation, EV and so on. Now coming to the policy part of it, in case, you mentioned some 3-4 technologies, I'm not sure if we have the time to cover each one of them, but if you take an example of EV, there was a lot of anxiety that was there among us, and we had actually given it terms like the consumer anxiety, the charge anxiety, the cost anxiety. And by 2030, we are aware that the Indian roads will see majority of electric vehicles. Now, taking a very small example of a policy, there is public infrastructure which is there. The first time there was a policy which was introduced, which was for the vehicles on highways, where you would use typically the fast charging policy. In the union budget last year, we had the battery swapping policy being released. So today first half we were discussing that whether a fast charging is more feasible or a battery swapping. Because for a battery swapping, again you are using a fast charging in order to charge it, and then a vehicle comes and you exchange it and so on. Also for the case of heavy vehicles, the kind of trucks and the heavy transport that we see, it may be 5% of the total transport, but they do utilize say around 35% of the diesel. So they form an energy intensive or a diesel intensive consumer segment for EVs. So that's where we'll have to see for different segments, looking at the India's demography, looking at the India's characteristics, the consumer behaviors. So one side you have highways where you'll go for high charging, fast charging. One side coming to the consumer level. In fact, I know we were discussing a few days back that we are talking of slow charging, we are talking of, lot of EV charging infrastructure around. But talk of the cities which are developing now, talk of your own societies. You could have RWAs, you could have, own operated buildings where they do not come under the ambit of a public charging infrastructure. So how do we enter that? And that is one unexplored area to take an example, but we may not per se have a policy like that, but after months of discussion, we do have a procedure that, if there is a EV charging structure to be set up in an existing society, if you have the fire officer's approval, if you have the safety officer's approval, then a public charging infrastructure could be set up in your own society. So this is a very small example when we come to the ground level implementation. Coming to the battery energy storage system, he's already covered the cost and the raw material aspect of it. When you actually integrate it into the grid, so the whole interesting energy mix that we are talking about is to meet those reliability standards. Now going to the old days, we are all aware of, we had boilers, we have DGs. Whenever there's one of the incomers that go off, you have a hot standby and so on. In case of batteries, again, we have regulations which are set up, so they would give you the window that, this is the voltage, the frequency, the power quality that we are looking for. coming down to the implementation, now we have requirements from the power plant developers where the grid would like to know what's the true representation of the kind of technology you are trying to fit in. So to take an example of a battery energy storage system, we would really like to see that in case there is a deviation, what is the ramp up time, what is the ramp down time, how fast, and what's the amount of backup that this battery energy storage system could give. And I think it's, no less than a Pandora's box, Saif, to open. Come to green hydrogen, come to electrolyzers, the modular ones and so on. So I would say it's, we are in a very good shape, a very progressive stage where India, we are moving fast towards the energy transition, and we are, other than the base load, as Tobias mentioned, we are trying to see the potential of different kind of mix of energies which would give us a good mix of reliability, affordability and sustainability, where we also have to understand that we talk of a new technology, we see it in a complete sustainability perspective, where's the raw material coming from, is it really cost efficient, is it really energy efficient, how do you dispose it of, is it a circular economy related to it, and so on. So, Saif, I think with the time available, I would like to summarize it is that every new energy is welcome, and let me tell you, every 2-3 years we will hear a new kind of disruptive technology, but a government policy is something which, as manufacturers, as grid integrators, as aggregators, we have to closely associate with, which forms a total optimum sense to integrate into India. So I look forward to many interesting times ahead. Thank you.
Thank you so much, Dr. Shivani. Thank you so much. With this, I think we come to a close to this panel discussion. And before thanking everyone, if there is any query, wow, I'm quite impressed with the energy in the room.
Thank you very much for a very nice session. We do recognize that when you have intermittent technologies that supply power, you need a large amount of baseload capable generating systems. And in the new world that we are talking of, the world is talking of nuclear being a substantial baseload supplier. So I am a bit disappointed that I was the only speaker that talked about nuclear. I'm hoping that both the CEA and the organizers will take care next session to have nuclear, and particularly get the Department of Atomic Energy here. And the second thing is a request to Malaysia, that you had a turnaround some years back where you had established the Malaysian Nuclear Power Corporation. And we had been in touch with Dr. Zamzam and Dr. Libai for a long time. So it was very nice to hear that have you taken any specific steps to get nuclear back on the roadmap? Thank you.
So thank you very much for the question and suggestion. Definitely, as I mentioned, the nuclear conversation has started a few months back, and we can see the journey of nuclear in Malaysia has been a very, I would say, a start-stop kind of scenario. And I'm very glad that you mentioned the names of the Dr. Zamzam, a very prominent person in Tenaga Nasional and in Malaysia with respect to nuclear. And the good news to me, because I think I do believe that we require the base load. The good news that we are having that conversation, and next month we are sending 2 of our former team members of the nuclear department in Tenaga Nasional to Geneva to attend a specific conference on the infrastructure of nuclear by EIAI, So that I think that is a positive step moving forward. Thank you.
Thank you so much. I think we can take one question. Sir, if you can allow.
Thank you. Hello. Thank you very much, Chairman. My question is not any question. I have some observation on the GIZ. GI have a good exposition of the how to make the supply and demand gap, how to fill up the supply. We have the morning have a session on our Minister Piyush Goyal, how to accelerate the solar energy, how to accelerate the solar energy as a local level. So my point at one sun, one world, one grid, one industrial estate. Why not put a road map to one sun, one grid, and one industrial estate, access to energy, access to human right, and access to energy, every SME as an ecosystem management.
Sir, before you answer, Vikram sir, you should please honor sir also. He has been the most active participant, at least today I have been seeing him, asking questions everywhere. So, anyone would like to?
Just very quick, it was more a comment of your side than a question. But from the perspective of government of Germany, nuclear is not an option. We are phasing it completely out because it's around 5 to 10 times more expensive than renewable energy sources. Base load is something I only hear in India. Countries which have advanced and high shares of renewables, they don't talk about base load anymore. Base load is something which you hear from the fossil world, but in a renewable energy-based world, it's all about residual load. No? So it's all about balancing and residual load. So base load is something which you don't hear in countries which have renewable energy shares of higher than 20, 30%. No? So Germany, we have 50%, but 50% is the annual average. So that means at some days we are shooting above 100%, no? And in some zones of the grid, we are even 200% renewables, no? So, yeah, this whole baseload thing. And then solar, please allow me one comment. There's one thing which is also a thing of my heart. I wish everyone could put it in YouTube and search for it. It's called agri-photovoltaics. There's big investments happening right now in the world, and more companies are looking into it. They're saying, why should we not maximize 1 hectare, the yield of 1 hectare? No? And if you know that compared to biofuels, you can run around 20 to 30 times further with the electricity produced in 1 hectare compared to producing biofuels, then why not better produce food and put the electricity, the solar panels above the food production and just use it for charging an electric vehicle. So my answer, one answer would be agri-photovoltaics is a big, interesting thing to actually look in India. Thank you very much.
Thank you so much. I think
Thank you. Thank you.
Session.
It was indeed a great session with a lot of questions from audience as well as from the moderator itself. Moderator was being a teacher today. So now I request Vikram sir and Sudhir sir for providing a memento to our esteemed panelists also. So now, first of all, I would request for Mr. Yasin. He has given an interesting presentation about Kashmir. A good round of applause for him. For our keynote address, Mr. Rajput. Now I request Sudhir sir to hand over a memento to Mr. Meghat. Now to Mr. Tobias. To Mr. Debi. And to Dr. Shivani Sharma. And the most important person who organized this session, to Mohammad Saif Saab. Now I request every delegate to please come near to the stage. We'll have a, okay, first session photograph, then we'll have a group photograph with all the delegates. Wait. I'll have photo on the photo. Remove the table. Photos on. Let they get photo done. Thank you. So we'll have a group photograph on the stage. Just a moment, sir. All the delegates who are present in the room, please come.
I also request our knowledge partners who are present here, please join us for this photograph session. Thank you.